5-foot ladder to the top of a 56-foot building. Calculate the distance from the bottom of the ladder to the base of the building and then compute the measure of the angle formed where the ladder touches the top of the building. Bring in the highlighters for this problem. In this problem, there is a right triangle. When you are given a diagram and it doesn't have like a directly drawn triangle in it, you have to find it. In this problem, it's not terribly complicated to find because the ladder is already on a slant, so that probably means it's going to be the hypotenuse. The side of the building is probably going to be like an opposite or an adjacent side, depending on which part of the information you need. And the ground, the base of the building, the base of the ladder, is going to be some sort of like either adjacent or hypotenuse. But you should draw just a very reduced looking geometric figure, taking all of the information in the building with the ladder and the fireman on it and turning it into nothing, having no context behind it, but still have the information and the details. 65 feet, so the little apostrophe means feet. 65 feet and 56 feet, and then some unknown value. It says compute the measure of the angle formed where the ladder touches the top of the building. So that's this angle up here. At first, I thought that they would want to know this angle right here, but that's not what that sentence says. So read very carefully and then take that reading and that understanding back into the problem so that you maybe can be efficient with your time. I legit, when I first read this and started this video like a minute ago, was thinking I would have to use Pythagorean theorem to find the third side of that triangle and then calculate my cosine. But we don't have to do that because the hypotenuse is always across from the 90-degree angle, and most buildings are built on a 90 so that they don't fall over. And then it says compute the measure of the angle formed where the ladder touches the top of the building. That's this angle. Theta is up here, and that makes 56 the adjacent side. You have to be able to spot that. So read very carefully and then put that information onto a triangle. And sometimes you need scratch paper where you do it wrong and you go, not that one. Don't ever erase, just draw a line through it and start over. And then we have, oh, it's up here. That's how I know where my hypotenuse and adjacent side is. Scratch paper to do the practice work ahead of time. We don't know the angle, and because we don't know the angle, you need inverse cosine. So our angle, no letter, we'll just use theta, is going to be inverse cosine of adjacent divided by hypotenuse. 56 over 65. You've got a calculator. On that calculator, it's in degree mode. Sorry, glare. It's in degree mode, and so in order to calculate with it, we're going to use cosine inverse of this fraction, 56 divided by 65. You don't have to fit it in fraction format. Fraction means divide. Just press the divide sign. And there we go. My angle, 30.51 degrees. Of course, I'm checking that it's in degree mode. You need to do the same. Whether you're using Desmos or your phone or another like calculator thing that's out there, degree mode for geometry. That other option is for like algebra 2. Okay, last question of this section. Diane trains, I can read. Diane trains for a charity bicycle marathon. She leaves her house at noon and heads due west, biking at an average rate of 4 miles per hour. At 3 p.m., she changes course to north, 65 degrees west, as shown. Label the diagram and determine the bike's distance from Diane's home at 5 p.m. This one, okay. So one thing we're going to need to do, I do notice that there's a triangle here that's similar to the larger triangle there. She leaves her house at noon and heads due west, biking at an average rate of 4 miles per hour. So she's leaving at noon, traveling at 3 p.m. That's going to be 3 hours of time traveling 4 miles per hour. So 3 hours at 4 miles per hour, hours cancel out, she's gone 12 miles. This is 12 miles. Okay, this is why these questions are tough. We have to read the word problem and take the information from the word problem into a diagram. Fortunately, they gave us a diagram, but we didn't have to do that. Now, she's heading due west. So due west is this way, directly headed that way. So this is where our 12 miles is. At 3 p.m., she changes course, and so now she's going to go along this stretch, and she's going to travel from 3 p.m. to 5 p.m., which is 2 hours, at 4 miles an hour. So she's going 8 miles. 2 hours, 3 to 5 is 2 hours, times 4 miles per hour. Hours cancel out, which means 4 times 2 is 8. And the units of measurement, oh my gosh, sorry, is miles. So this section right here is 8 miles. She's got 12 miles there and 8 miles there. Oh, I know. Okay. Label the diagram and determine the bike's distance from Diane's home at 5 p.m. So we need to know this entire unknown. How far away from home is she right now? And what I notice is this hypotenuse and this adjacent side are all that we actually need to focus on. No, I'm sorry. Determine the bike's distance from Diane's home. Okay, I need to be a little more clear. This line right here, label the diagram. So there I am labeling it. And then I'm determining the bike's distance from Diane's home at 5 p.m. That's this line. Okay, back on it. We have layers of cosines to do. And there might be an easier way that's not jumping directly to my mind. So I'm going to launch into how I'm intentionally going to try to solve this. I'm going to start here. I'm going to find this distance. Yep, I'm going to find this distance. So I'm going to call it x because I don't know it. And I'm also going to recognize that the way that this 90-degree angle is formed here, well, the other side of it is also 90 degrees. So these two angles, the 65-degree one, and then the rest of it also form 90-degree angle total. So to find out this little angle that's left, it's 90 minus 65. Theta in this little corner is 90 minus 65, and I know that to be 25 degrees. So cosine of 25 degrees is x over 8. The x for adjacent and the 8 for hypotenuse, and I need to know the value of x so that I can then add all of that to this problem and be able to find the max distance in the x direction. Multiply both sides by 8 to solve this problem. So times by 8 there, times by 8 there, the 8's reduce. And now we go to the calculator. And I'm going to use my phone calculator for this one just for the sake of practicing it and bringing it to your understanding. So phone, turn the phone sideways. And it says radian right now. I'm going to press that. I'm going to do a quick calculation. I'm going to do 60-degree cosine. If you get a negative, you're in radian mode. And I don't want to be in radian mode, I want to be in degree mode. So I'm going to press that button again and just check. 60 degrees cosine, I get 0.5. Okay, that's my quick check to know that I'm doing the right mode. Cosine of 60 is 0.5. Clear all. Now, this calculation. To find x, you work backwards when you're using this phone. You do 25 in the phone, then you hit the cosine button, so that the calculator knows you want to know the cosine of 25. Right? Calculators like on the phone like this, or a scientific calculator, they always kind of work in a path that's backwards. That says, what do you have? And I'm going to do something to it. So I'm going to do cosine to 25. Now I'm going to do multiplication by 8. Enter. X is 7.25 miles. I know it's 7.250462229, whatever. Just truncate after the third decimal, and the third decimal is a 0. The number after the 0 is 4, so then the 0 is going to stay as 0. X is 7.250 miles. And if we already know that she's gone 12 miles, then adding both of these together, her total distance from home is 12 plus 7.25. Now, by the way, this is total distance in the west direction. We still need to go north and find how far up she is here. So I'm going to go 12 plus 7.25. I know that to be 19.25 miles west. Okay. Okay, now what do we need to do? Somehow I have to get that line, the actual distance from home, involved. I'm trying to look at similar triangles. I'm just not seeing those similar triangles. There is the small triangle, and it's similar to the big triangle. But I don't know what this angle is. And it's not 65, because the 65 or even the 25, it's not the 25 either. Those are based upon, one, this pink line and this green line, they're not parallel. And only when lines are parallel can they have corresponding angles that are congruent. So my green hypotenuse and my pink hypotenuse are not parallel, so they're not making congruent angles. This 25 degrees, this is not 25 degrees. So I still don't know it. We've been talking about cosine inverse. I'm just not seeing my cosine inverse problem yet. Maybe it's not a cosine inverse problem. It's just continue solving with trig. Let's continue solving with trig. You know what I realize I need? I need to know this opposite side. Because now, if I know the opposite side, I can go continue through Pythagorean theorem. So I'm going to find this opposite side by doing 8 squared minus 7.25 squared. I'm going to call that the y because it is kind of like a y-axis. And so I'm going to say that my y equals Pythagorean theorem. So I'm using Pythagorean theorem. I'm just skipping over a bunch of the initial steps. But 8 squared minus 7.25 squared is my Pythagorean theorem application. And I'm just going to use Siri for a second. Hey Siri, what's 8 squared minus 7.25 squared?
The answer is 11.4375.
Hey Siri, take the square root of that answer.
The square root of 11.4375 is approximately 3.3819.
Okay, so I have my y distance right here, 3.382. I'll just abbreviate it at 2. So if I want to find the distance of the pink line, it's just another Pythagorean theorem. I use trig with cosine to get this far, but now what I need to do is use trigonometry to figure out the pink line. I know this line, so now I just use Pythagorean theorem again, and I can find the distance of pink. And it's time to actually just write the whole thing in pink. This is my answer. Determine the bike's distance from Diane's home at 5 p.m. So the distance, d, will be 3.3819 squared plus 19.25 squared, and then I need to use the square root. This is, again, the Pythagorean theorem. A squared plus b squared, and then to figure out what c, or the other side is, you have to square root the answer. Hey Siri, what's 3.3819 squared plus 19.25 squared?
3.3819 squared plus 19.25 squared is approximately 381.9997.
Hey Siri, what's the square root of that answer?
The square root of 381.9997 is approximately 19.5448.
Answer. Cosine is the adjacent side divided by the hypotenuse. And once you know two sides of a triangle, you can keep using trig. However, you could also use Pythagorean theorem, and that's what I'm using right now. Thank you for watching this video. Thank you for liking, commenting, and subscribing. We're wrapping up our conversation on cosine, the adjacent side divided by the hypotenuse. And in the next video, we're going to summarize and review sine, cosine, and tangent.